Okay, we're learning about inverses. And it's actually chapter 5, even though we are now in chapter 6. Chapter 6 involves inverse functions, so you got to learn what inverse function is first. So when we talk about inverses, we talk about opposite operations. So the inverse of multiplication would be the opposite of multiplication, which is division. What's the inverse of subtraction? What's the inverse of power?
Square root.
I didn't say square root. I said, yeah, root. Alright, so we're going to first start and learn about inverses by doing this exercise. We're going to learn about inverses by doing this exercise. It says first change f of x into y. Okay? Because you know f of x is the same thing as y. So first change it into y. Then it says solve this equation for x. So we're going to get x by itself. What am I going to do to both sides? Take away 3. So now I will have y minus 3 equals 2x. And then what? Divide by 2. And I'm going to write x equals first, because I like to write it that way. I will have y minus 3 over 2. So what we've done is we've taken an equation and we've just solved it for the other variable. When we go and we think about the original equation, we think about x being an input. And we think about f of x or y being the output, or the domain and the range. So the second part of this equation says find the input, which is which variable? The x. Find the input when the output, which is which variable? Is -7. So we're going to take that equation that we just had, and we're going to make y -7 and find out what x is. So taking that equation at the bottom that you switched, you're putting in -7 for y, and we're going to solve that, and you're going to get 10 over 2, so x is what? -5. So what that is telling us, if we go back to the original question, that is telling us if we put in x is -5, we should get y is 7. So I can just check it real fast. If I input f of -5, if I make x equals -5, what do I do on the other side? If I do f of -5, what do I do on the other side? All right, wherever you see an x, make it -5. So we do 2, x is -5 plus 3. So we get -10 plus 3. So we get -7. The output is -7 when the input is -5. So that's just proving what it just said up there. Okay. I'm going to come back and talk about this in just a moment. But let's try that. Maybe for number 2 and 3, let's not do all 3 of them. Let's try that for 2 and 3. You're going to first solve the equation for the other variable, and then you're going to put in the output and find the input. We're going to do the exact same thing we just did. So we'll just do 2 and 3, not all 3 of them. We'll just do 2 and 3. So the first thing I'm going to do is I'm going to change this one to y equals 2x squared. And we're going to solve for x. So what do we do to both sides? The first thing you need to do is divide by 2. The first thing you need to do. Now what do you do? What if you do the square root yourself? You put in the square root yourself.
Plus minus.
So I get that x equals plus minus square root of y over 2. And it says, find the input or inputs when the output is 2. So I'm going to put in y is 2. I'm going to have x equals plus minus square root. Now y is 2 over 2. Then x equals plus minus, what's the square root of 2 over 2? 1. So you have 2 answers, plus minus 1. That means if you went back up to the very original question and you put in 1 for x squared, and then multiply by 2, you should get 2. Or if you put a negative 1 and square it, multiply by 2, you should also get 2. Which it works. Okay, how about number 3? First make this y. Oops, and copy it correctly, which is a number. We're going to solve it for x. What should I do first? Subtract the 3. Alright, this is where we had trouble before. What's my next step? Divide by negative 1. Then what do I do? Cube root. Do I need plus minus with cube root? Not for odd. So get x equals the cube root of y minus 3 over negative 1. And they're telling you that the output is 2. Where do I put that output? For y. And we'll just simplify that. We'll get the cube root of negative 1 over negative 1, which is the cube root of 1, which is 1. So x would be 1. And y is 1. So you guys have almost done the lesson for today. Almost. So inverse functions and inverse operations are opposite. So now I'm going to go back and talk about example 1, and it's in your notes. We're going to talk about example 1 when we switched it around. What they have here is they have the original question, and then over here they have how we switch it around when we solve for x. And when you talk about what's being done to the x variable in order, you say first multiply by 2, then add 3. That's what's being done to the x. And when you go over here and you talk about what's being done to the y, you say first subtract 3, then divide by 2. And when you notice that, over here was multiply by 2, over here was divide by 2. That side was add 3, over here was subtract 3. And they're in the opposite order. This is how you completely undo things. This is what our inverse functions have to do with. They're totally opposite operations in the opposite order. On the next, oh, no, just kidding. At the bottom, they just talk about what I just said out loud. And then something else is the inverse functions. And the inverse functions, what they basically do is they switch the x and y roles. They switch what the input and the output is. They completely switch x and y. They switch. I'll show you in a second. But because we're switching x and y, anything that has to do with x and anything that has to do with y also switches. So the domain and the range completely switch too. So x and y switch and the domain and range switch. Everything that has to do with x or y switches. And then on the next page we have a graph of that same example. So here's the original function 2x plus 3. And what they did was they wrote the inverse function as switching the x and the y. So instead of y minus 3 over 2, they now wrote it as x minus 3 over 2, and they made this y, but they called it a different y than that y. So they switched their x and their y. You see? They've switched their x and the y. If you look at the graph, this will happen every single time we have inverses. When we graph these two graphs, they made a table and they graphed them. They are reflections over this y equals x line. They are reflections over the y equals x line. You see, if I folded the paper on that line, they would totally match up. Something else that you need to notice is the ordered pairs that are graphed over there. They've written over here. And if you look at negative 2, 1 in the original function, there is an ordered pair, negative 1, negative 2 in the inverse. If you look at the ordered pair negative 1, 1, in the inverse there's 1, negative 1. If you look at the ordered pair 0, 3, in the inverse there's 3, 0. What can you summarize about the ordered pairs in the original function and the ordered pairs in the inverse function? They switch x and y. The ordered pairs switch x and y. So we're going to find an inverse. We're going to graph it. We're going to graph its inverse function from scratch. You're going to use these steps to follow when you do your assignment. So we're going to write down steps, and I haven't given you a ton of room. You might have to write kind of small, and this is where I'm going to start using colors. Just remember that we are switching x and y for the inverse. We're switching x and y for the inverse. So here we go. Find the inverse of f of x equals 3x minus 1. So first thing I did is I just rewrote the equation because I needed it where I could do stuff to it. You probably won't have to do that part of your homework because I gave you space after that, but there was too many words there. Step 1. Make f of x into y. Get rid of that f of x, let's make it into y. Remember, f of x is y, so we'll just change it. That's the original function. It's just written as y equals instead of f of x equals. But that's the original function. Okay, my next step is how I find my inverse is I'm going to switch x and y in the equation. That's step 2. Switch x and y. So instead of y equals 3x plus minus 1, we're going to have x equals 3y minus 1. Step 3. Solve equation for y equals. I'm taking my equation and I'm going to make it y equals. So what will I do to get y by itself? Do what? Plus 1, add 1. And then divide by 3. So I'm just going to write it as x plus 1 all divided by 3. Then step 4, if the inverse is a function, which I haven't told you how you determine that or not, but this one is. I will show you how to determine that in a moment. But if it is a function, write y as g of x. So my last step is I'm going to take y and I'll write g of x equals x plus 1 over 3. And that should be my inverse function unless I made a silly mistake or not following the rules. So you first just make f of x into y. Then you switch x and y. You solve for y. Then you change it to g of x. Okay? Now we're going to graph both of those. And depending on what kind of equation it is, you have to remember how to graph all these because we graphed them this whole year so far. So this, you look at this original one, plus you read the directions, and this says it is what kind of equation? Linear. Should make a line. So when we go to graph it, actually before I, what did you say? What did you say? Huh? I heard somebody say linear. Okay. Before we go to graph it though, let's graph our y equals x reflection line. Because if we do this correctly, it will reflect over the y equals x line. I'm going to have that there. You get the straight edges. Y equals x reflection line is when x and y are the same number. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Do I need to keep giving you more examples? Yes, -1, -1, -2, -2, -3, -3, -4, -4, -10, -10. You have straight edge, you don't need to graph every single point. You have straight edge. So no, it should not be a lot of work. We're going to graph f of x equals 3x minus 1. We're going to graph the original function. So f of x equals 3x minus 1. Since it's a line, I can find the slope. And I can find the y-intercept from day 1 of school. Plus algebra 1. And hopefully geometry. What's the slope? 3 over 1, or 3. What is the y-intercept? -1. So we begin at 0, -1, and we use our slope and go up 3 over 1, up 3 over 1, up 3 over 1. Or down 3, left 1. Or you could use your straight edge at this point. Now you have two ways of graphing the inverse. You could find the slope and the y-intercept of the inverse and graph it that way, or you can use my suggestion, which is way easier. So you could find the slope and the y-intercept of this fractional equation, which does not look fun to me. Or you can use the fact that inverses have x and y, but they just switch every single ordered pair of x and y. They switch to x and y. So when I look at this blue one and I see points like 0, -1, and I see this point here that is 1, 2, and I see this point here that is 2, 4, no, 2, 5, sorry, looked at it wrong. And then this point up here, which is 3, 8, If I just take each of those ordered pairs and I switch them. -1, 0. 2, 1. 5, 2. 8, 3. And I use my straight edge to connect that. Or I use my slope if I want to find more points. It's much easier. You just switch the X and the Y. And after you graph it, you say, does it look like it reflects over that line? Does it look like it? Does it look like if you folded that paper in half, it would reflect over that line? Hey, if you need to check it, do that. Fold the paper if you need to check it. But if your X and your Y, all the ordered pairs are just switched, then it will look like that. If all the ordered pairs are just switched, it will look like that. So we're not going to have time for all those student practices, but we're still doing the exact same thing on the next page. They're just not lines on the next page. So when you're ready to go on, go to the next page. We're going to do the next example. They're just not lines. It's the same stuff, just not a line. So when we have nonlinear functions, you can still find inverses of them, but sometimes they're not functions. We're going to talk about what's a function and what's not a function, and we're going to find the inverses the exact same way we found them with the other one. To know if something is a function or not a function, you need a vertical line. You know, if something's a function or not a function, you need a vertical line. You take this vertical line, and you don't have yours in color, mine's in color up here, but the blue one, which is the parabola, if you just look at the parabola in this big fat red line, how many times does the parabola intersect this vertical line at any point? The blue one, not the red one, the blue one. How many times do they cross at the same time? Once. When I go to the red one, how many times do they cross at the same time? Twice. You see how the red line and the big fat vertical line are intersecting twice? But in the blue one, it's always one. So if it intersects more than once, it's not a function. So over here, the blue one is a function, but the blue one is not a function. So when you look at the two equations for this first example, they have the blue one written as f of x equals x squared, but they do not have their answer written as g of x. What they have instead is they have like the y still in it, and I would solve that for y. I would have y equals plus minus square root of x. I would solve it by square rooting. But I'd still leave it as y equals. I would not write it as g of x because it's not a function. So the only thing we have to do with function or not a function is when you write your equation, if it is a function, you'll write g of x. If it's not a function, you're going to leave it as y. So on this one over here, if you look at the red line, you can see it only intersects once. That's why the red line is g of x on that one. So I'll give you an example of one that is and one that's not a function. Now this one should not say quadratic, it should say nonlinear. Okay. So we're going to find the inverse of f of x equals cube root of x minus 4, minus 2. we're going to graph both. So the steps are the same. First step, make f of x say y. Step 2, switch x and y. And that's the inverse right here. This is the inverse. But we have to solve it for y now. We're going to solve it for y, but that is the inverse. Once you've switched the x and the y, you have the inverse. So we're going to solve it for y. So what am I going to do first to solve it? There. Well, look at the equation. What am I going to do to get y by itself first? Okay. So I'll have x plus 2 equals cube root y minus 4. If you do not pay attention during this part, you're not going to know what to do. What do I do next? Harley, what do I do next? Cube both sides. Perfect. Now, I am not going to FOIL all of that out. I'm just going to leave it as cubes. There's nothing that says I have to simplify. We're just solving it. We don't have to simplify it. Yay. Now what do I do? Add 4. So we'll have y equals x plus 2 cubed plus 4. And we need to decide if that's a function or not a function to decide if I write f of x or I'm sorry, g of x or if I write y. Well, we might have to graph that first if we're not sure. So let's do the graphing. Before I start graphing, I'm going to take my straight edge and I'm going to graph y equals x. So remember, y equals x is 0, 0, 1, 1, 2, 2, 3, 3. I hope I don't have to do that yet. Graph my y equals x line. Then I'm going to graph my original function. We just took a test on how to graph cube root. That was on your test. So you could use a table if you need it, or you could graph your parent function and transform it. I'm going to graph my parent function and transform it. Here's my parent function for cube root. What transformations are happening to the blue one from the original parent function cube root? The blue one. What transformations are taking place in this blue one? What's minus 4 mean? Right 4. And then what's minus 2 mean? Down 2. So each of these ordered pairs, I'm going right 4, down 2. Each ordered pair, right 4, down 2. Can you guys pay attention, please, or stop being disruptive? One or the other. So that is the blue original function. The red one is my inverse. So I need to just take each ordered pair and switch x and y. That one's way off the graph. I'm not going to worry about that one. This one right here is 5, negative 1. So if I have 5, negative 1, then I'm going to graph negative 1, 5. If I have 4, negative 2, I'm going to graph negative 2, 4. If I have 3, negative 3, I'm going to graph negative 3, 3. Here I have negative 4, negative 4. I will graph negative 4, negative 4 still. When we look at the two equations, they should be reflections over that y equals x line. You can pull the paper if you need to check. You can also plug in the equations to check on your calculator if you want to. Is the red one a function? Would it pass a vertical line test, or would it pass more than once through the vertical line? What do you think? Is it a function or not a function? Should I get a vertical line for you? What do you think, this red one? Does it pass more than once or just once? Just once. So this is a function. So we will write our inverse as g of x equals x plus 2 cubed plus 4. It was a function. Do all those same steps again with the next equation. All those same steps again with the next equation. Consider the function f of x equals 2x squared plus 1. Let's make that y equals 2x squared plus 1, and that's our original function. How do I make it into the inverse? How did I do it? Switch x and y. Yeah. So x equals 2y squared plus 1. So there's our inverse. Well, we can't graph the inverse the way it is right there, so we're going to have to solve for y. So we will take away 1. And we will divide by 2. And then we're going to square root both sides, which I'm going up here to finish it. When I square root both sides, I need plus minus. X minus 1 over 2. Before I finish my inverse, I have to decide if it's a function or not a function, so I might need a graph for that. Until you figure it out by yourself, you might need a graph for that. So we'll go ahead and graph them. Start with the y equals x line. Start with your y equals x line. And to graph 2x squared plus 1, I used tables before to do that. When we were doing transformations, we used tables. So I'm going to start with the parent function, just x squared, and I'm going to put the ordered pairs in for x squared. So negative 2, negative 1, 0, 1, 2, and then square that 4, 1, 0, 1, 4. That's the x squared parent function. What's the transformations to this? What's the 2 tell us? Vertical stretch by factor 2. So we take our vertical, our y values, and multiply by 2. 8, 2, 0, 2, 8. What's the plus 1 mean? Up 1. So that is also to the y values. So now we add 1 to the y values. 9, 3, 1, 3, 9. And remember, you only graph the outermost x and y. So negative 2, 9, negative 1, 3, 0, 1, 1, 3, 2, 9. Should that look like a parabola? Should that look like a U shape? We've graphed this before. Is that one a parabola? X squared? Quadratic? Yes. These are all graphs you've done before. How am I going to graph the inverse? Aiden, what do you know about the ordered pairs of the inverse? Zeta, what do you know about the ordered pairs of the inverse? They switch x and y. So here's a table where I have all my x's and my y's. So if I graph negative 2, 9 for the regular function, Aiden, what will I graph instead? 9, negative 2, that will be my inverse. 9, negative 2. So instead of negative 1, 3, I'm going to graph 3, negative 1. So instead of 1, 0, I'm going to graph, I'm sorry, I said that totally backwards. 0, 1, I'm going to graph 1, 0. So we're going to graph all of these inverse ordered pairs. And it should look like it reflects over that y equals x line if you've done it correctly, which mine looks like it. So is the red one a function? If I took a vertical line, would it cross more than one? Yes. So that is not a function. You leave it as y equals. You don't write it as g of x. That's the only difference between if it's a function or not a function. Leave it as y equals instead. That's our inverse function. It's not bad if you follow the steps. All right? While you're turning the page, stand up and do like, get your mind out of wherever it is, because these last ones are going to be confusing. So, like for real, stand up and like, and like, get back into it. We don't have a lot of time, but like, yeah, 30 seconds, do it. I'm telling you, you're going to be lost otherwise. If you got colors going to help you on this one. 2. I mean, the colors could be pencil and a color.
Yeah, that's all I do.
Okay, get back to it. Let's do it. Let's do it. If you need to stand up to make yourself pay attention, you can. If you need to do this one, that's fine. Because the last page, the very last section, we are doing proof. When you see the word verify, when you see that word verify, when you see that word verify, when you see that word verify, it means you're going to have to prove it. Okay, to prove it, you are doing f of g of x. So we got two functions. We have to prove that these are or are not inverses. And to prove that, you have to take the g function and stick it in the f function wherever there's an x. If they are functions, it will equal x when it is done. If it equals anything else, they are not functions. And then we'll do it a second time over here, where over here you're going to put the f of x function inside of the g of x function where the x value is. So here we go. Everything that is f is in blue. Everything I have that's g is in red, so hopefully you can follow it. Okay, so I'm going to do f of g of x. So I'm going to take my f of, and I'm going to put my g into it. So I'm going to put x plus 1 over 3. inside of my f function. So I started copying down the f function. I put f parentheses, but there's an x. So instead of x, I made it x plus 1 over 3 equals c. Then I put the equal sign. The next thing I'm going to have is a 3. After that 3 is another x. But wherever there's an x, we're putting the g function. So we're doing x plus 1 over 3. And then finally, to finish out that f function, I have minus 1. So I just took this entire f function and copied it, but instead of x, I put the g function. Now you're going to do nothing. Don't touch this side over here. Do nothing over there. On the other side, we're going to simplify. So on the right side, we're going to do 3 multiplied by x plus 1 divided by 3, and then minus 1. So you think, all right, if I take x plus 1, and I divide it by 3, and then I multiply by 3, what does divide by 3 and multiply by 3 do? So I just get x plus 1, and we bring down minus 1. Now, if I have plus 1, and then I have minus 1, they cancel out, and we get x. And the goal was to show that it does equal x. So you will have to organize your work and show it like this. Beautiful. Organized. In line. Then you go over to the other side and we do the exact same thing, only this time we're putting we're putting the f of x inside of the g. So I'm going to start with the g function. I'm going to start with g. And wherever you see x, I'm replacing that with the f function. So wherever I see an x, I'm making it 3x minus 1. So I took the entire g function, and wherever I saw an x, I made it 3x minus 1. And you don't touch the left side. You only simplify the right side. So on the right side, at the very top, I have 3x, then I have minus 1 plus 1. So 3x minus 1 plus 1 is now 3x. On the bottom, 3. And what happens with 3x over 3? I get x. And that's what I want to have. So we have verified that these are functions. Just that easy. Yeah. No. Your hand was. Okay. Let me, so that's what you're going to be doing for, like, on your assignment. I'm going to do 11. I'm going to go do 11. So if you need to color coordinate, I'm making anything that's f of x blue. And anything that's g of x, I'm making red. And we're going to do, f of g of x. And then we're going to do g of f of x. And we have to show that those equal x. Alright, so you're going to take your f function and wherever you see an x, put it with g of x. So we're going to have f of cube root 2x equals, and then you got to do 8. And there's another x, so I do cube root 2x, and then there's a cube that's originally part of the x. And we don't touch the left side, we're going to touch the right side. We're going to cube it first. I'm going to have 8 multiplied by, you have to do the cube root of 2x cubed. What happens when you have a cube and the cube root? Cancel each other out, we get 2x. And then you multiply those together and you get 16x. Does that equal x? So these are not inverses. Or you made a mistake. Well, I'm gonna say that they're not. How are you gonna know if you made a mistake? You're gonna do the other one just to check. So both of them shouldn't work. If one works and one doesn't, you probably made a mistake. So we're gonna do the g. You do g of, and then you're gonna put your f inside, and the f is 8x cubed. Equals, and we're gonna do the cube root of 2 times, and then there's my x again, so I'm gonna do 8x cubed. Then the cube, I wish I knew why I did that. I'm going to have the cube root of 16x to the third. And then we've learned how to do this, so you can break that up and do cube root of 16 and cube root of x to the third. And that's going to give me x. Is this going to give me something other than the number 1? Is the cube root of 16 something other than 1? Because this has to equal x. Is it going to equal x? It's not. This is actually going to equal 2 cube root 2, so 2x cube root 2. I did that really fast, but you can see that it does not equal, so these are not inverses. So I expect the most questions on this part. Do not wait till the last minute to start it, because you're totally going to forget about it. I will post this video if you need to go on and rewatch that end section. And if I didn't do a good job of explaining it, I bet you can find like way better videos on the internet anyway. You guys have a short 10 question assignment on the words. Sorry. Carl.